Welcome to the deep dive. Today, we're getting into something that affects, well, pretty much all of us.
Yeah, everyone who has a kitchen or a laundry room, really.
Exactly. We're looking at this surprisingly gripping guide from an appliance repair service down in Bradenton, Florida.
Right.
It's called Stop Killing Your Fridge, Expert Appliance Repair Secrets for Bradenton Homeowners.
A very direct title.
Oh, very. And our mission for this deep dive is to figure out how we're all, inadvertently suffocating our expensive home appliances.
Suffocating is definitely the right word for it.
Yeah. And we want to extract these localized expert secrets from the guide that can honestly save you thousands of dollars. Because normally when we think of a home emergency, we expect drama.
Oh, sure. Like a tree branch smashing through the living room window.
Right. Or a pipe bursting in the basement with this huge cinematic spray of water everywhere. It's loud, it's obvious, and it demands your attention right that very second.
Right. It's an event. You can point at the broken window and say, there's the disaster, let's go fix it.
But then you step into the everyday world of homeownership.
Yeah.
Specifically, the appliances we rely on to keep our lives running.
Yeah.
And suddenly that disaster landscape just goes completely silent. It's sneaky.
It really is.
We treat these massive metal boxes like they're just indestructible servants. We expect them to run 24/7 without a single thought toward maintenance.
Right. Until they don't.
Exactly. Then the inevitable happens. You wake up on a Tuesday, open the fridge, and find like a puddle of lukewarm milk.
The worst way to start a morning.
Truly. Or you open your dishwasher and it just smells like a literal swamp.
Oh, yeah. That smell is unmistakable.
And suddenly, your grocery investment is melting. You're frantically Googling repair techs.
Yeah.
And you're in this quiet but very expensive nightmare.
Which is, it's the absolute definition of creeping normalcy. We just do not see the failure happening until the motor completely gives out.
Right.
But as the source material points out, almost all of this is entirely preventable.
So preventable.
Yeah. Now, to set the scene, this guide is focused heavily on the harsh 90% humidity environment of Bradenton, Florida.
Which sounds miserable, honestly.
Oh, it's a lot. But even if you live in, say, the driest part of a landlocked desert, do not tune out.
Yeah, it still applies to you.
Exactly. The environmental stress test is happening in Florida, sure, but the underlying mechanics of appliance failure, they apply perfectly to your own kitchen.
Right.
Florida is basically just this extreme testing ground that accelerates and reveals the universal vulnerabilities of these machines.
Okay, let's unpack this.
Yeah.
Because I really appreciate viewing Florida as the ultimate stress test.
Yeah.
And if we're treating our appliances like indestructible servants, the hardest working servant in the entire house is definitely the refrigerator.
Oh, without doubt. It never gets a day off.
Never. So we need to look at the number one entirely preventable reason that refrigerators fail.
Yeah.
And spoiler alert for everyone listening, the primary cause of fridge failure is almost never some mysterious defective part.
Right. It's not a computer glitch.
No. It's dust. Literally just dust and pet hair.
Yeah, we tend to think of appliance death as this highly technical event, right? Like, you need a degree in electrical engineering to understand it.
Right.
But we are really just looking at basic physics. Because a refrigerator doesn't actually make cold air.
It doesn't.
No, it uses condenser coils to shed heat from the interior. It absorbs the heat from your groceries and it just pushes it out into the room.
Wow. Okay. I think this is where the everyday neglect really happens. Because I am completely guilty of this.
Oh, most people are.
When those condenser coils, which are usually hidden underneath or behind the fridge, right?
Yeah, exactly.
When they get caked in regular household dust or, hair from your golden retriever, the fridge cannot shed that heat.
It traps it all in.
Right. It's basically like a marathon runner trying to run a 26-mile race while wearing a heavy, thick winter coat.
That is a perfect analogy.
Right. The machine is just suffocating under its own heat. The compressor has to work twice as hard to push the thermal energy through that layer of insulation.
Yeah, that marathon runner analogy hits the nail on the head. Because if the heat cannot escape through the coils because of that blanket of dust...
It just builds up.
Exactly. The compressor ends up running constantly instead of cycling on and off like it's supposed to.
Oh, man.
And that constant strain, it shortens the mechanical lifespan drastically. Plus, it can spike your energy bill by up to 35%.
Wait, 35%? Just from dust?
That's from dust, because the motor is pulling continuous electricity.
That's wild. But the fix is so easy, isn't it?
So easy. The guide states that cleaning those coils with the simple vacuum brush attachment takes maybe 10 minutes.
10 minutes.
Yeah. Doing that twice a year, or, quarterly if you have shedding pets, can add 5 entire years to the machine's life.
Okay, 5 years of life for 10 minutes of vacuuming is just a phenomenal return on investment.
It really is.
And while you're down there on the floor with the vacuum, the guide introduces this brilliant, simple diagnostic called the dollar bill test.
Oh, I love this one.
It's for your gaskets.
Yeah.
Because the rubber seal around the door is the only barrier keeping ambient room heat out of your freezer.
Right.
So you take a single dollar bill and you close the fridge door on it. If you can pull that dollar bill out with zero resistance, your rubber seal is shot.
Yep, it's compromised.
Yeah.
And the mechanism behind why this is so destructive goes way beyond just cold air leaking out.
How so?
Well, when a gasket warps or flattens over time, it allows warm, humid kitchen air to seep into the freezing compartment.
Okay.
And when that humid air hits the freezing evaporator coils inside, the moisture instantly turns into frost.
Oh, I've seen that buildup before.
Right. Then the fridge's internal sensors detect all that ice buildup and force the machine into a constant defrost cycle.
Oh, no.
Yeah. The compressor works overtime to cool the fridge, while the defrost heater works overtime to melt the frost. The appliance is effectively fighting itself.
Fighting itself until the compressor just burns out. So you are literally paying money every month to air condition your kitchen floor while simultaneously pushing your compressor to an early grave.
That's exactly what's happening. And a new rubber gasket is a cheap, do-it-yourself fix. You pop the old one out, push the new one in.
Wow. Ignoring it leads to a massive financial punch to the gut.
It really does.
But it's crazy that we suffocate the outside of the fridge with dust, yet water is actually the common denominator for appliance failure.
Oh, definitely.
Because the moisture creeping into a fridge from a bad gasket is subtle, but the moisture trapped in our dishwashers is glaringly obvious.
Oh, yeah.
We just ruin these machines from the inside out.
Moving from the exterior physics of the fridge to the absolute chaos happening inside the dishwasher is a perfect pivot.
Chaos is the right word.
Because the general consensus among homeowners seems to be that a dishwasher is just like a secondary garbage disposal.
Okay, I will admit I have definitely treated the dishwasher like some sort of magic portal.
Most people do.
You put a plate covered in baked-on lasagna in there, you close the door, press a button, and just expect the mess to disappear into the ether.
Like magic.
Right. But the guide is very clear that modern dishwashers are not magically vaporizing our food.
No, they're not.
They are machines with incredibly delicate, tiny holes and fine filters.
Yeah, and the evolution of the appliance itself is to blame for this misconception, really.
What do you mean?
Well, older dishwashers from a few decades ago were incredibly loud, specifically because they often had a built-in hard food macerator.
Wait, like a blender in there.
Basically, yeah, they literally ground up the food like a sink disposal.
Oh, wow.
But consumer demand shifted. People wanted whisper-quiet kitchens. So to achieve those low decibel levels, manufacturers completely removed the internal grinder.
That makes sense.
Yeah, and to compensate, almost all modern, quiet dishwashers now feature a manual clean filter sitting right at the bottom of the tub.
Meaning you actually have to twist it out and wash it with your own hands.
Yes. Hand wash the dishwasher filter.
And if you don't, the guide describes what collects in there as a disgusting gray sludge of trapped food particles.
It is so gross.
Yeah. And if you do not clear out that sludge, the physics of the machine actually work against you.
Exactly. What's fascinating here is the water pump takes the water from the bottom sump and pushes it up into the spray arms.
Right.
If there is sludge in the water supply, your dishwasher essentially becomes a high-pressure sludge cannon.
A sludge cannon.
Yeah.
That's a horrifying image.
It pushes those tiny particles into the spray arms, clogging the microscopic holes that are supposed to be cleaning your dishes. That is exactly why your plates come out gritty.
Ah, okay, that explains the gritty plates.
Yeah.
But beyond gritty plates, the stagnant water situation becomes a severe health issue too, right?
Oh, absolutely. Especially in regions like Bradenton, or really any warm environment, water pooling at the bottom of a dishwasher becomes a breeding ground for mold incredibly fast.
Yuck.
And the homeowner's first instinct is usually to call a plumber or an appliance tech, assuming the internal drain pump has failed.
Sure, that makes sense.
But before paying a massive service fee, the source material urges you to look at the drainage system connected to your sink, specifically the air gap.
Right. We all see that little silver cylinder sitting next to our kitchen faucet every day.
Yep.
But the guide points out this terrifyingly simple vulnerability inside it. The air gap is designed to prevent dirty sink water from siphoning backward into your clean dishwasher.
Exactly.
But because the dishwasher drains its dirty water upward through that specific line, the guide notes that a single stray popcorn kernel lodged in that air gap can shut down the entire drainage system.
It's crazy, and the fluid dynamics at play here are remarkably straightforward.
How so?
Well, that air gap cylinder is designed to be a narrow bottleneck for air and liquid, not for solid matter.
Okay.
When a kernel or a piece of hard debris gets pushed up into that gap, it acts like a perfect cork, and water will always take the path of least resistance.
Right.
Since it can no longer drain out into the sink pipes, the dirty water simply flows backward, filling your dishwasher tub with standing water.
Wow. One single popcorn kernel causes a microscopic flood in your kitchen, all because the machine was treated like a garbage disposal.
It is fascinating that water destroying our appliances doesn't just happen in physical tubes or black drains. It actually happens in the air around us.
Yeah, the ambient air.
Which brings us to the most destructive, invisible force attacking our machines, the climate factor.
This is huge.
Here's where it gets really interesting. We usually think of high humidity as just being physically uncomfortable. Like it makes you sweat, it's terrible for your hair.
Exactly.
But this Bradenton guide paints ambient humidity as a slow-motion wrecking ball for a motherboard.
A total wrecking ball. When the ambient humidity in your home consistently rises above 60%, your appliances are basically breathing in suspended water vapor.
That's a wild way to think about it.
Yeah, and it has two very distinct, very dangerous consequences. The first is highly visible and physical, specifically concerning your clothes dryer.
Okay.
High humidity makes the lint in your dryer incredibly sticky.
Right. Because normally the dryer's lint trap catches the bulk of the fibers and the rest just blows out the vent line to the exterior of your house.
Exactly. But when the air is thick with humidity, that lint gets damp and heavy.
So it just sticks.
Yeah. It adheres to the interior walls of the venting system, building up layer by layer until it creates a severe blockage.
And the thermodynamics here are dangerous, right?
Very. If the air cannot move through that vent, the heating element inside the dryer, which is essentially just a giant glowing metal coil, has nowhere to push that intense thermal energy.
Oh, man.
The temperature rises until the metal filament exceeds its melting point and simply snaps. Best case scenario, your dryer is broken.
And the worst case?
Worst case scenario, that trapped sticky lint ignites and you have a major house fire.
Which is why the vent lines must be cleared annually all the way to the outside wall, not just at the lint screen.
Exactly, not just the screen.
But the second consequence of this coastal climate is what happens on a microscopic level to the electronic control boards.
This is the invisible part.
Yeah, the guide specifically mentions the coastal salt air in places like Manatee County. Saltwater vapor is not just corrosive to metal, it is highly conductive.
Meaning it carries an electrical current.
Exactly.
Yeah.
But let me push back on this for a second, because the advice here seems a bit extreme.
Okay, let's hear it.
Modern appliances, your oven, your washing machine, your fridge, they're basically large computers with complex electronic brains now.
Oh, definitely.
The guide says that when salty moisture settles onto those delicate circuit boards, it causes something called bridging.
Right.
The water forms a conductive puddle between two copper traces that were never supposed to touch. The electricity takes a shortcut, and the board shorts out completely.
Yep, he fries the brain.
So the advice is to keep your home's internal humidity below 60% by running your air conditioner or a heavy-duty dehumidifier. But aren't you just shifting the cost?
What do you mean?
Well, you're saving the oven's motherboard, sure, but you are spending an absolute fortune on your electric bill by running your AC around the clock in a place like Florida.
Okay, that is a completely valid concern regarding the electric bill. But we have to look at systemic failure versus localized costs.
System failure.
Yeah. An air conditioning unit doesn't just cool the air. Its primary function is literally to condition it by removing moisture.
Oh, right.
If you allow the humidity to stay at 80% inside the house to save $50 a month on your electric bill, you are not just risking the oven.
You're risking everything.
Exactly. You are simultaneously exposing the logic boards of the refrigerator, the dishwasher, the washing machine, and the dryer to that same conductive salt vapor.
Oh, wow. I didn't think about it like that.
Replacing just one proprietary logic board can easily cost $600 in parts and labor.
Huh?
Replacing 3 of them wipes out years of energy savings.
That's a really good point.
So running the AC is essential armor for the microelectronics running your entire home.
That makes perfect sense when you multiply the risk across every appliance in the house.
It's the only way to protect them.
But even with perfectly conditioned air, even if you are vacuuming your fridge coils religiously and cleaning out the gray sludge, time eventually wins.
Time always wins.
The physical components degrade. Which leads us to the ultimate homeowner dilemma. How do you know when to fix a machine and when to just let it die?
This raises an important question, really. It comes down to overcoming the sunk cost fallacy.
Right.
You've invested heavily in the machine, so your natural instinct is to try and save it. But knowing when to stop applying CPR is a crucial financial skill.
The guide uses ovens as a great example of this degradation because they're fairly simple machines, but they're heavily neglected until your cakes start baking unevenly or burning on one side.
Yeah, people ignore ovens until they ruin dinner.
Exactly. An electric range is built to last about 13 to 15 years. But just like the fridge, the oven door has a gasket to trap heat.
Yep.
Over time, the constant expansion and contraction make that gasket brittle. The hinges start to sag under the weight of the door.
And you can actually see the physical evidence if you look closely.
You can.
Yeah, there'll be dark soot marks around the exterior door frame where the intense heat is escaping.
Oh, I've definitely seen those soot marks before.
And just like the leaky fridge gasket, a leaking oven door forces the internal heating element to stay on much longer than it should to maintain the target temperature.
Which burns it out faster.
Exactly. It leads to premature burnout of that filament. The guide offers a highly practical tip here, though.
What's the tip?
If your oven is struggling around the 7-year mark, you don't necessarily need a technician right away.
Okay.
Buy a cheap analog oven thermometer at the grocery store, put it inside, set the oven to 350 degrees, and check the actual internal temperature against what the digital dial says.
That's super simple.
It is. If the physical thermometer is off by more than 25 degrees, it is time to get it professionally calibrated.
Okay, but let's talk about the point of no return, though. So what does this all mean for the weekend warrior who wants to fix everything with a YouTube tutorial? Let's say I have a 6-year-old washing machine at home.
Yeah.
A standard washer lasts about 10 years, so it's past the halfway point of its life. Let's say it breaks down tomorrow, and the technician tells me it needs a $400 motor.
Okay.
A brand new basic washing machine is about $800. My instinct is to just pay the $400 and fix the motor because it's cheaper today than buying a new one.
Sure.
But the guide introduces the industry standard 50% rule, which tells me that is a terrible idea.
The 50% rule is designed to protect you from the cascading failure of older machines. It's a two-part equation.
Okay, break it down for me.
First is the cost of the repair more than half the price of a brand new machine. In your scenario, $400 is exactly half of $800.
Right.
Second is the unit more than halfway through its expected lifespan. Yes, at 6 years, it is past the 5-year midway point of a 10-year lifespan.
Okay, so yes to both.
Because the answer to both is yes. The rule dictates you let it go.
Just let it die.
Yeah. If you put a new motor in an aging machine, the transmission or the water pump will likely fail next year. You are much better off taking that $400 and putting it toward a brand new Energy Star rated model.
See, I know a lot of people listening are weekend warriors who are thinking, well, I can bypass that expensive labor cost. I can buy that same washing machine motor online for $200 and install it myself using a YouTube tutorial.
I hear that all the time.
But this brings up a deeply sobering warning from the guide about the absolute limits of do-it-yourself repair.
Knowing your limits is the hallmark of a smart homeowner. The guide from Bradenton, citing warnings from Sears Home Services, is absolutely adamant that there are lines you simply do not cross.
Like what?
Well, never attempt to fix a gas leak yourself, which seems obvious.
Yeah, leave gas to the pros.
But they also highlight microwaves, dishwashers, and ovens. Many of these modern appliances contain high-voltage capacitors.
Right. For those who might not know, a capacitor essentially stores energy, almost like a temporary battery, correct?
Precisely. Household electrical current is often not powerful enough to get a heavy washing machine drum spinning from a dead stop, or to power the magnetron in a microwave.
So they need a boost.
Yeah, a capacitor stores a massive amount of electrical energy to deliver a huge, instantaneous jolt of power.
Okay.
The critical, incredibly dangerous detail here is that a capacitor acts like a dam holding back water. It can hold a lethal electrical charge for days or even weeks after the appliance is completely unplugged from the wall.
Wait, really? So you pull the plug out of the outlet. You think you're totally safe because the machine has no power.
Right.
You open the back cabinet of the microwave, and if you touch the wrong wire, you could receive a lethal shock.
Yes. Unplugging it simply stops the capacitor from refilling. It does not empty the bucket of electricity that is already stored inside.
That is terrifying.
If you are not 100% sure how to properly and safely discharge a high-voltage capacitor using an insulated tool, you have absolutely no business opening up the exterior cabinet of that appliance.
No business at all.
The risk of electrocution is extraordinarily high.
That is an incredibly important warning to end on. To summarize this deep dive, the source material presents you with a very stark, very clear choice.
It really does.
You can spend 30 minutes a month doing the absolute basics, vacuuming the dog hair off the fridge condenser coils, twisting out that manual filter to wash off the gray sludge in the dishwasher, and making sure your air gaps and lint traps are perfectly clear.
The easy stuff.
Right. Or you can spend thousands of dollars replacing an entirely new kitchen suite every few years.
That's the reality.
The margin for error, especially if you are battling humidity and coastal salt air, is incredibly slim. Treat your appliances with an understanding of the basic physics they require, and they will actually work when you need them to.
It's a powerful shift in how we view the maintenance of our homes. But the shift toward microelectronics leaves me with a final, lingering thought to mull over.
Oh, what's that?
Well, we've discussed how modern appliances are essentially computers now, highly sensitive to moisture bridging their circuit boards.
Right, the brains.
It presents a fascinating paradox. As our homes become increasingly smart, heavily reliant on delicate motherboards, Wi-Fi connectivity, and complex digital sensors, are they simultaneously becoming far more fragile?
Oh, wow.
It makes you wonder if the highly efficient, high-tech smart homes of our future will actually require significantly more manual, hands-on babysitting from us than the clunky, durable, analog appliances our grandparents used decades ago.
That is a brilliant paradox to chew on. Are we trading long-term durability for short-term digital efficiency?
Exactly.
Well, ponder that. I highly encourage you to go grab a $1 bill right now, walk into your kitchen, and test that fridge door gasket. You might just save yourself a burned-out compressor before the day is over. Thank you for joining us on this deep dive.